the idea here is to take the ln of both sides, and certainly you don't have to write this because I'm not going to finish it, right? But what happens when I take the ln of that whole right side is it splits into two ln's, right? So I get the ln of the 2x minus 5 to the fourth plus the ln of the 8x squared minus 5 to the negative third. That's a property from pre-cal, property of logarithmic functions. And now the other property is that exponent comes down, right? So I now have 4 times the ln of 2x minus 5 minus 3 times the ln of 8x squared minus 5. So again, property of ln's. And now when I go to take my derivative, I'm using that ln derivative of the inside prime over the inside. So I get y prime over y. I get 4 times 2 over 2x minus 5. Notice the 2 is the derivative of the inside, and then it's over the inside, right? Minus 3 times 16x over the inside, 8x squared minus 5. So after this, it turns back into the other problem right away. But the key is, and make sure you agree with me, that you know where the 2 came from and where the 16x came from. So the rule that we have for ln, right? If y equals ln of u, I get y prime is u prime over u. So derivative of the inside over the inside. Yeah. Yes. If it was ln of a divided by b, it would be ln of a minus ln of b. And that's basically, if your pre-cal teacher taught it to you like this, it's basically when you're adding when you're multiplying like bases, you add exponents. That's why I'm adding ln's. And when you divide like bases, you subtract exponents. That's why I'm subtracting ln's. Of course, the trickiest part is not the calculus, it's the algebra, right? It's not the calculus that's tough, it's the algebra that's tough. Anything else I can do? Any problem you want me to answer? Any of the quizzes I just gave back to you? Any of the old exams that I've posted? Yeah, Ethan. No problem. Yes. Yeah, so I'll write it like this. This is the first way we ever learned how to do exponents, right? Is we did something like this, and then I can see that these will cancel. So I get 1 over x. So, right? So it's the same as factoring. We're trying to just get things to match, and then I can pull them out or I can cancel them. Yeah. How we doing? We okay? Good. Let's try a problem together. This is from test 3 from last semester. Let's do number 10. The secant of the arctan of 2. We did this. Wait, we did this one yesterday. Oh, we did it slightly different, right? Secant of the arctan of 2 over x. I'm going to write it here. So we want to find y prime, right? In terms of x. Good, I'll give you a couple minutes. And of course, our first thought is what? That we have a theta, right? We have an angle. Which one are we talking about? Yeah, it's 2 over x, right? Which is what? 2 times x to the minus 1. So the minus 1 comes down, and then I subtract 1 from minus 1. That's minus 2.
Yeah, I know that. But when we did the homework, you made it negative 3 go between the 2.
What? I made it what?
The equation we just did for the homework, you made 8x squared minus 5x to the power of negative 3 goes to the power of negative 2, and we want the denominator. What's the difference?
Yeah, but the 3, when I moved that whole term downstairs, it became positive. When I moved that whole term downstairs, the 3 that was negative became positive.
Yeah, well, how come the other one's different?
No. You're confusing this one with the exponent rule. Power rule. Take the derivative of that. The 3 comes down, and then I subtract 1 from 3, which is 2. But on the one I'm doing right now, this is a x to the minus 1. The other one is is something to the third. So y prime, I'm sorry, you're working, I'm working. I did that again, didn't I? Thank you. Okay, how many of you got the triangle correct? None of you got the triangle correct? Anybody else? Did anyone get the triangle? Thank you. Arsima, you didn't get the triangle? Do we understand where the triangle's coming from? Everybody understand where the triangle's coming from? If I have an inverse trig, I have a theta, which means I have a trig, right? So here's my trig. And I know the ratio of tangent is opposite over adjacent, so 2 over x. And then I use Pythagorean theorem to find the other side, right? Right? A squared plus b squared is c squared. So 2 squared plus x squared is equal to c squared. So 4 plus x squared is equal to c squared. So c is square root of 4 plus x squared. Right? How is it useful? I want the answer in terms of x. So when I get down to secant theta times tan theta, that's not in terms of x. So, but I can look at the triangle and get the ratio for the secant, hypotenuse over adjacent. So I replace that. I already know that tangent is 2 over x, or I could again look at the triangle. Nice. Yes, question?
You want the derivative of like secant or tan,
Yeah.
you don't want to do derivative of like secant or stuff like that. You just want to keep it like that.
Well, no, I do need the derivative of the outside function in this case, which is secant. Then I need the derivative of the inside function, which is inverse tangent. Yeah, right here, right here. So everything I'm doing up to that point is setting up the problem, setting up that triangle. You did this a lot in your trig class, in your pre-calc class. You set up triangles. Question? Yes? Hey, Cyril. Those are your quizzes there. Those are your quizzes, yeah. You have your mask today? You gotta go downstairs and get one, I'm sorry. Yes, yes. Absolutely. So let me just go through the whole thing here. And I am recording, Cyril. So I instantly see that I have an inverse trig. And I want to really think of that as an angle. So I got the angle. But I don't think in terms of inverse trigs. I think in terms of trigs. So I want to take the tangent of both sides. And I end up getting tangent of theta is 2 over x. And that's what helps me create my triangle, which I need. Sometimes I'll need it, sometimes I won't. Okay? Sometimes I'll need it, sometimes I won't. But make it anyway. Anticipate that you will need it. So now I'm going back to my original problem. If you see, I've rewritten my original problem as secant of theta. Y is secant of theta. So now I'm ready to take my derivative. I get y prime is secant theta tan theta, and I need theta prime. I need the derivative of the inside, which of course we already know is an arctan, and we know the process to get an arctan derivative. What is the process? I got to find u, I got to find u prime, I have to find u squared. I found u prime, I found u squared. On our formula sheet, we have y equals arctan of u. implies y prime is u prime over 1 plus u squared. And so that's what I did here. I put u prime over 1 plus u squared. Oh, I forgot that square root one. Thank you. Now, everybody with me so far? Yes. Long problem, right? Go ahead, Tia. Oh, yeah. So now I'm replacing my secant with the ratio from the triangle, right? Do you see it? Ratio is hypotenuse over adjacent. Square root of x squared plus 4 all over x. Tangent is 2 over x, right? And then I'm just simplifying this thing as much as I can. I don't want fractions within fractions. So I get an LCD here, right? Oops. I get an LCD here. And then I keep simplifying. Well, so where are you at? Do you have a final answer? Yeah.
Simplified it. This is u prime. I simplified it before.
Yes, this is correct.
Okay,
And I just have a negative, yeah. You lost your negative somewhere here. See that negative there? You didn't bring that in, did you?
Got it.
Nice. It's good.
Are you bringing down the negative two right here? Right?
Yeah, exactly. That's right? This is a numerator, this is a denominator, right? I'm kind of doing keep, change, flip there. Keep, change, flip. Yeah, so keep the numerator. So it's negative 2 over x squared. Change the change to multiply, and then flip the denominator. Keep, change, flip. Again, you don't have to do your algebra and your arithmetic the way I do it. I might skip several steps that you don't want to skip, right? So you make sure you're doing the algebra on your own. Let's look at an easier one, but strange, okay? Let's look at an easier one, but a strange one. Yep.
I don't know which form to read. So like no double fractions. But what about square roots? Those are allowed in the bottom of it.
So say that again. How do we know which?
What form to read it?
You want it completely factored. So if there's anything shared top and bottom, you want to cancel. Right? Any?
The square root can be in the bottom.
Yes. Yeah. We used to say no, right? But after Calc 1, Calc 2, we don't care anymore. Yeah.
So,
Mike.
so what stops you to multiply the negative 2x squared on with the numerator by the tan 2 over x is 4.
I do have that. I just did it in my speed. Okay? Good. Let's do another one like that, but strange. And let's do y equals the sine of the arc sine of x. Now, if you remember your inverse trigs, what does this thing really become? What? Not 1x, right? So y equals x, which means y prime is 1. Sine and arc sine cancel each other, right? If you're in the right quadrants, but we're always going to be assuming we're in the correct quadrants. But let's do the same problem, right? As if I didn't realize, and let's see what happens to the derivative. So when I do y prime, what do I get for derivative of the outside? Derivative of sine is what? Cosine. Still at theta, right? But now the derivative of the arc sine of x right? I need a u. Oh, that's just x, right? I need a d. I need a u prime, which is 1, and I need a u squared. Okay, that's. I'm sorry. I could have gone right to my problem here. Sorry. Cos of theta times what? 1 over square roots of 1 minus x squared, right? Yes, you with me? But what is x? That's my problem here. I know theta is the arcsine of x. What is x? Yeah, so when I see an inverse trig, it's an angle.
So cosine theta of arcsine x is the same thing as
Yes, theta is arcsine of x, yes. So, but what is x? If theta is the arcsine of x, what is x? Yes, but that's sine, right? That's sine of theta, yes? Okay, so now look at what I have. Cos of theta over square root of 1 minus sine squared theta. What is 1 minus sine squared theta? Yeah, it's cos squared, right? Square root of cos squared theta. And so that's cos of theta over cos of theta, which is 1. So know the process. Do the process, right? Question, not no.
Okay, so for the other functions, the theta is 2 over x, you figure that, right?
No, theta was the arctan of 2 over x. Right? Look at it. Theta is the arctan of 2 over x. If you see an inverse trig, you have a theta. If you have a theta, you have a trig. So you have a triangle. Yep. So I have an inverse trig, don't I? So that means theta is arcsine of x. So no, but think about it. Inverse function. What's the inverse function of arcsine? Sine. What do inverses do? They switch their input and output. So sine of theta, this is not a calculus problem, okay? This is a pre-calculus problem, right? That's where you're having trouble, but that's okay. So sine of theta is x, or theta is the arcsine of x. Those are interchangeable because of the inverse functions. Yep. So it's that inverse function piece that's screwing you up, I think, right? But if I see theta is arcsine of x, I instantly know sine of theta is x. Exactly. Exactly. So, I mean, there's a definite need for a review of some of the pre-cal, right? If you're having trouble with the log functions, if you're having trouble with the exponentials, if you're having trouble with rational functions, having trouble with inverse functions, having trouble with trig functions, right? Then you've got to go back to your pre-cal book if you still have it. If you don't have it, chapter 1 in our book is all pre-cal. Yes. So chapter 1, inverse functions and logs, exponential functions, right? So, and then I think there is some pre-cal in the back as well. There's trig, a section on trig. I think I'd rather you go back to your pre-cal book. Or go to the library and borrow a pre-cal book. One more? Yeah? I'm afraid of improvising and coming up with something that's horrible, but I'm going to do it anyway. Let's see if y is the arcsine of tangent of theta. Well, this one seems a little strange, right? Arcsine of the tangent of theta. So it doesn't quite feel like I need a triangle here, but we'll see what happens because it's just an arcsine function, right? So when I know this, I know y equals arcsine of x implies y prime is 1 over, sorry, arcsine of u is u prime over 1 plus, sorry, square root of 1 minus u squared, right? That's my shortcut I have memorized, so I think I can go right to that here. So what's the value of u? Yeah, tan of theta. What is u prime? Secant squared theta. And what is u squared? Tan squared theta. So I think I can go right to that. Y prime is secant squared theta over the square root of 1 minus tan squared. And then I'm going to be thinking, I got to come up with, I should try and simplify this, right? But I'm not quite sure I can. The only thing I can try is I know that sine squared plus cos squared is what? Sine squared is 1, right? I'm going to divide everything by cos squared. And I get tan squared plus 1 is secant squared. So there's not really much I can do here, right? I guess I could put a tan squared in as, so tan squared is secant squared theta minus 1. Let me try that. I don't know, right? I don't know if it works. This looks pretty simple already, but so I'm doing square root of 1 minus what tan squared is. And that is secant squared theta minus 1. Again, I don't know if I need to go further here. I don't know if it's going to get easier. Well, what do you see that happens? Yeah, I'm going to get a secant squared theta over the square root of a negative secant squared theta. Right? So I'm thinking no. I'm thinking no, that doesn't look right to me. The ones cancel, right? Oh, no, they turned to 2. Okay, thank you. No. So no, it's not, doesn't even work that way either. So no. When I tried to simplify it, it got more complicated. Well, so originally I could have said arcsine of tan of x. It doesn't matter if I use x or theta or what. I could originally just said tan of x. Yeah, so it's just I'm just pretending theta is the x variable. Another? Yes, another? Let's do y equals the tan of the arc sine of 2x. Do I need a triangle here? Yes. What do you see as your triangle? Theta is what? Nice. And that means instantly what? Without skipping a beat. I don't think in terms of inverse trigs. I think in terms of trigs. So what trig am I talking about? It's obvious. Sine. So sine of theta is what? 2x. Inverse functions switch domain and range. So now I have a triangle with a ratio of 2x over 1, and the other side is square root of 1 minus 4x squared. I'm doing that Pythagorean theorem in my head very quickly because I do them every year now for 10 years, right? So, but if you want me to show that, I will. Yep. So let's pretend for a second I don't know this side, and I'll call it A. So I know a squared plus 2x quantity squared should equal 1 squared. Yeah. Yep. So a squared plus 4x squared equals 1. So a squared is 1 minus 4x squared, and when I take a square root, right, that's when I get that side A. You okay? Good. Let's take our derivative now. d dx of y should equal d dx of the tan of theta. I just don't feel like writing out arc sine of 2x, but that's what it is, right? So on the left, I get y prime. That's what I wanted. On the right, derivative of the outside function is nice secant squared of theta. That's still the arc sine, times theta prime, right? Times the derivative of the inside. What do we need to do a derivative of an arc sine? We need a u. We need we need a u prime, and we need a u squared. So I get u prime, that's 2 over square root of 1 minus 4x squared. How are we doing here? You feeling more comfortable with this? Good. Only one nod. 2 nods, 3 nods. No. 3 out of 7. Almost half. Almost. How can I get my secant from the triangle? What is secant from the triangle? Nice, 1 over a. So I get 1 over the square root of 1 minus 4x squared, still times a 2. I got to square that, right? Secant squared. Yes, agreed? So it looks like I get a 2 over 1 minus 4x squared to what power? 3/2. Because I've got a 1, when I square the one on the left, right, it's a first power, and the other one is a half power. First power plus half power is 3/2 power. I'd probably give you 9 out of 10. I mean, the stroke count there is huge, right? 1, 2, sorry. 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, 11, 12, 13, 14, 15, 16. So 15. 1, 2, 3, 4, 5, 6, 7, 8. A lot of characters missing. And remember, we're trying to communicate as much as possible to our project leader, right, to our boss, in with brevity. I want it to be as short and as clean as possible. Question?
I understand why it's like that, and then the reason for that.
Where are you?
I'm telling you why it's doing.
Oh, okay. So a to the 1 times a to the 1/2 is a to the 1 plus 1/2, right? And that's 2 halves plus 1/2, so that's a to the 3 halves. Right? Not the calculus that's hard, right? Nice. Let's take a little break. Let's come back at 1:15.
Is there another problem with just like this?
Say again?
Can I have another?
Yes. Yes. Let me find one that I actually gave